Hello, today I will record my 15th video about the Math Olympiad Theorems, but after this I will need to take some gap and try to record another type of videos. In this video, we will discuss Hall's marriage theorem, which tells us that if we are given two components of graphs, x and y, both of these sides are equal to each other, and we know that for every subset of S of x, size of S is less or equal to the size of neighbors of S in Y, then we can find the perfect matching between X and Y. Here we will prove this by using the induction. For one, it's clear that if we are given 2 points, then A and B can be connected and we can find perfect matching. Now we will prove this by using the strong induction, and let's assume that this is correct for K and prove this for K plus 1, length of the x and y must be k plus 1. In this case, we will discuss two different types. Then we can find some set S such that S prime equals neighbors of S primes in Y. In this case, take any subset S prime and its neighbors, G of S prime. In this case, by using the induction, we can find the perfect matching between S prime and G of S prime. And now look at the remaining numbers. Because their size is same, and we know that for every subset of S prime, size of subset of S prime will be less or equal to the appropriate neighbors of the subset to the G of S prime. Now let's look at what will be x prime equals x minus s prime, and y prime be y minus g of s prime. Now we will prove that x prime and y prime will satisfy the initial condition. So for every set m of x prime, size of m will be less or equal to the neighbors of m in y prime. If now assume that this is not correct, by using the contradiction method, we will prove that this is correct. So we have found some number m such that size of m was greater than neighbors of m in y prime. So this means that if we choose s prime plus m in the original problem, size of s prime plus m will be greater than size of g of s prime plus m, g of m. And clearly this is the contradiction of the initial statement, that this is clearly some s second prime, s2 prime, which is also subset of x. There we know that this s prime, s2 prime must be, size of s2 prime must be less or equal to the g of s2 prime. And this is against our condition that we have proved that s prime plus m has greater length than the g of s prime of m plus g of m. So by using this, we have proved that for every m, the size of m must be less or equal to the g of m in y prime. And if it is correct, now we can apply the induction to x prime and y prime and s prime and g of s prime. And by combining these two inductions, we have proved this for x and y. Now let's discuss the second case. Then for every set of s, subset of x, size of s is less or equal to g of s, size of g of s, minus 1. And now take any 2 points, A and B, and connect them to each other. A is from X, this is A point, and this is B point in Y. If you connect these 2 points, and now look at new X prime be X minus A point, and new Y prime be Y minus B. Now we will prove that x prime and y prime will also satisfy the initial condition. And now let's assume that there we can find M subset of X such that size of M is greater than size of G of M in Y prime. This is Y prime and this is in X. Now look at what can be said about the M in the original X. Size of M must be less or equal to the G of M minus 1 where M was in the Y. And what can be changed after we are considering M in Y prime? At most one point will be cancelled out from the neighbors of M, and this point must be B. So this means that we need to take the at least G of M minus 1. And clearly this was our condition. In this case we have discussed the case then all of the subsets has neighbors. Neighbor set will be greater than this number, so it will be at least one greater than the original M. And if we subtract B to their neighbors, nothing will be changed to our original set, because in Y prime and X prime size of M will be always less or equal to G of M, because we have subtracted 1 to both sides and nothing will be changed. So we have proved for every M this will be less or equal to G of M, where M is from Y prime and M is from X. Now we can X prime. We can apply the induction to X prime and Y prime once again, and plus connecting A and B, then we can get the perfect matching from X to Y. So the main idea was to discuss two different type of configurations. Then the X is the set the S prime was equal to its neighbors in Y if two such sets exist, and the second case was that size of M was always at less than G of M in the Y, and after subtracting one vertex B from the Y, nothing will be changed, and initial condition will be also satisfied. So this was all I want to discuss for today. If you will be interested in some theorems, please write in the comments, and don't forget to like and subscribe my videos.